camera. So some pretty bright lights here. So very briefly, I'm going to talk about some new security stuff in Lollipop Android 0.5. Maybe you have seen them, maybe some of them you've used them already. This is going to be more about how those things works or how they're implemented internally. And there is 6 main topics, starting from, the first 3 are relevant even if you're a developer, not like a platform developer, like application developer. You might be using them. They have just introduced the APIs. And the last 3, they are more like platform stuff, lower level. If you're developing applications, probably you don't care about it, but it's still good to know. So first thing is multi-user support. It got some pretty new features, also a lot of new stuff around device management. And the third one, probably you've already using it if you have like Android 5 Smartlock. Full disk encryption has got a lot of press because Apple did it and then Android did it, and why? Verified boot is not so well known. It's still not. It's like kind of a work in progress. And SE Linux is of course hardening the platform. It's been there for a while. It's getting updated. So to start, the multi-user support, there is a few things. First is multi-user for phones. Before it was like only for tablets. Now phones also have it. Guest user is also something that's been around the code base for a while, but now it's like enabled and fully functional. Managed profiles. It's also interesting feature which kind of enables enterprise applications to manage like a part of your device, not everything. You can have your personal applications and then your business applications running on the same device with different security policy. And the last one is like before only the owner user, the first user could change some settings. Now they are like really truly multi-user. So to start with, this is how this stuff looks like. This is the UI for multi-user on phones. You can have one primary user, then secondary users, guest user. You can add more users. For user setting, this is a feature toggle allow phones and SMS. This is kind of a new thing because in the previous 4.2 to 4.4, the Android compatibility definition is stated that the behavior of telephony, that is SMS and placing and receiving calls, is undefined if there is more than one user. Therefore, you cannot have multiple users on phones. Now it's well defined. For some users, it's enabled, and you can toggle it. And the last one is security. Before, only the primary user could install certificates and trust agents and whatnot. Now is per user. Every user can have their own certificates and keys and etc. So there are also a few constraints. Restricted profiles are required for tablets. So if you want to have a tablet running 5.0, it has to support restricted profiles. Maybe you've used it already. It's a pretty useful feature where you have a user which is based on the primary user. It's not completely independent. It shares the application of the primary user, but they can have their own data. So like if you have a kid, you can just enable the games for him or her, and the rest of the stuff, you just turn it off. On the other hand, phones must not support restricted profiles. That's why if you have a phone with Lollipop, you cannot have restricted profiles. You can have multiple users, but not profiles. Managed users, they have to be, we'll talk about this in a bit, but for managed users, you have to have a thing like a small graphic called a badge, so you can know which application is for the primary user, which is for the managed user. And last thing is removable media SD cards must be encrypted. So if you have multiple users, you cannot just take out the SD card, put it in your computer, and read the data for another user. Guest user is pretty simple. Only one can be active, and you can enable it, and then there is like a user state, a guest session, and if you give it to somebody else, they can continue as the same user, or they just can wipe it off and start clean. So it's kind of a transient user. If you just give the phone to somebody for a while, don't want them to see all your pictures and emails and whatever, you can just enable guest user and then give it to somebody else, you clear it. The guest user can make calls by default, which is kind of an interesting decision. Manage profiles, they are for BOID, maybe this is the main target, where you use the same device for your personal stuff and if your company stuff. They are edited and controlled by device admin. They are independent from the personal profile, but still there is a unified UI, like in the same launcher. You see your own apps and the company apps. Also notifications, you would receive notifications for both, for your personal stuff and the company stuff. There's a thing, controlled intent resolutions. You can make them completely independent, or you can add some intents which can be resolved by the primary user's applications. And of course, full disk encryption is required for this to work. This is how it looks. If you want to enable it, you get a sort of a wizard, and which makes sure that you meet all the requirements, like encrypt your phone, creates the user, and etc. And when it's ready, you get this little, I don't know what it is, a suitcase, I guess, badge for the for the managed profile app. So you have like a Play Store, and then again Play Store, and then in settings, for some settings, you have personal and work profiles, so you can have different administrators and different settings and whatnot. So the API, it's relatively simple. You can use the action provision managed profile. If you start this intent, the system will start the wizard I showed in the previous slide. When the whole thing is complete, there is a profile provisioning completed, a callback, so you know it's finished. When you receive this callback, you can call profile enabled to start the whole thing. There's also APIs for clearing the cross-profile intents, the enabling system apps, and blocking uninstall for like the most three four apps which are required. So the implementation, which is like the, I don't know, Google reference implementation, it will disable pretty much all system apps. So the managed profile has, I don't know, maybe it's only downloads and settings, no, not settings, maybe a few of the system apps, and everything else needs to be enabled or installed independently. There's a thing which is called Google for Work. It's still not been released, and presumably for Lollipop, Google for Work will be based on managed profiles. How this all is implemented under the hood, a managed profile is just another Android user. So the same if you edit a different user, so say user directory, separate settings, and whatnot. The packages are managed in the package restriction XML, like on the previous version. What is new is this cross-profile intent filter element, which is it's basically a list of the intents which can be resolved by the parent user. So if you have if you add more to this list, for example, here you're saying that if you press the settings icon on the managed profile, you will get the setting apps from the main user, because there's only one. Another thing in device management is device owner. This has also been around until since 4.4, I think, but it was like hidden. You could sort of enable it if you wrote the system app. Now there is a officially supported provisioning method, and a few APIs in the device policy manager class. So device owner is basically a device administrator with extra privileges, cannot be enabled or removed. You can see here, usually you can uncheck this for device owners is disabled. Device owner can create and remove other users, can change system settings. As of now, only one can be active. And the provisioning is over NFC. How you do it? The supported method is by ndef, like a specially formatted ndef, which is delivered by NFC push, or what is the official term? When you bump two devices and they sort of connect. So what is it? Oh, okay, so in order for this to work, the device has to be unprovisioned, and what this means is that two system settings, device provisioned and user setup complete, have to be unset, have to be 0. So with a regular device, if you reset the phone, it is in this state, so you can do the device owner provisioning. What provisioning does is downloads an APK automatically and checks the checksum, the hash, and then installs it and enables it. How you do it? Basically, you have properties. You say what's the name of the package. You say what's the download location. You say what is the checksum or hash. You serialize this properties file and put it in a ndef message with a provisioning NFC type. So once you enable a device owner, you can use some additional methods of device policy manager which are only available to the device owner. It's clear device owner, set user restriction. You can change secure settings like disable and enable side loading and things like this. But there is stuff you cannot change because there is an internal whitelist. And then we are going to the next one, is trust agents, right? Maybe you've heard about it as Smartlock. What it does, it notifies the system when the environment is to be trusted. Trust can be temporary or expires automatically. You can disable it if you have the device owner or another administration application. The funny thing is kind of to be expected. It requires a platform signature, so unless you're doing like a custom ROM or you're customizing for a mobile carrier, you cannot really create a trust engine and publish it on the Play Store. The API is very simple. On the system side, there is a trust manager service which kind of manages the trust agents and deals with managing trust, enabling, disabling trust agents. And what it does, in order to communicate to the trust agents you install, there is a bunch of callback like unlock attempt, trust timeout, and setting and enabling some features. On the opposite side, communication from the trust agent service to the system service, there is another callback binder interface. You can grant trust or revoke trust. And again, first you need to call set managing trust to, not kind of notify the system that you are going to manage trust. In order to enable this whole thing, you have to basically create a service, extend from the trust agent service. You have to require this bind trust agent permission. So to make sure that only the system can connect to your service, you have to require those two permissions, control key guard and provide trust agents. Both are system signature permissions. So you have to sign the APK with the platform key in order for this to work. And finally, there is a resource XML file you can specify, which is used for the UI, like a label, description, and things like that. You can grant trust based on anything. You can be some system broadcast, you connect to a network, you enter and exit a location. It can be an NFC event, like touch another device. You can be polling some service. It really doesn't matter. So once you have captured your event, what you do is you call the grant trust method, which kind of notifies the system that is currently in a trusted state. You can pass a message, a duration, like for how long you're going to get run the trust, 5 minutes, 10 minutes, indefinitely. And there is a flag initiated by user, which seems to be unused at the moment. As I said, there is 2 permissions they are required, both signature permissions, so this kind of only works for if you control the platform, like we have the signature key, or you're building cyanogen mode or whatever. Another thing which is kind of related is Nfc Unlocked. Originally, this feature was it was independent from the trust agents, and then they were sort of merged together later. So the Nfc Unlock, like you may have seen it in, I don't know, I think the Moto X had it like last year or something. We have a special tag or even an NFC tattoo or whatever. If you touch the device, it unlocks. And the reason this could not be implemented in KitKat and previous version was that basically Android, in order to save power or make it more secure, it required for device to be unlocked in order to use NFC. So if you're like sitting at the lock screen, the NFC was like turned off. So even if you touch something, the system wouldn't register it. Now with 5.0 Lollipop, you can install an Nfc Unlock Handler, which is basically a component which gets called once something happens on the lock screen, like a tag is scanned. There's very simple API. You can have the add Nfc Unlock Handler to add handlers, which again requires a system permission. This time it's write secure settings. You can install multiple handlers. They are called in a loop, so only one of them needs to return true. And the way you work with it is basically you get a reference to a tag, and you can do whatever you want. You can pull data from it. You can communicate with it if it's an active tag. And you return true if you believe that this is a genuine tag. So Smartlock is the Google brand, like the Google implementation of trust agents. Very easy way to check this. If you use this dump sys trust, you can see the currently active trust agents. And in a stock device, you only have this Google Trust Agents, which is part of the GMS package, which is basically Google Play Services. There's a bunch of other data, if it's connecting, if it's managing trust, etc. So the API you've probably already seen. In the UI, the Smartlock, you can add a trusted device, trusted place, or trusted face. If you add a device, you get a warning like for Bluetooth, the range can be up to 100 meters, so the device can be unlocked even if the trusted device is not actually in your hand or even in the same room. And you can turn the whole thing off with this toggle, which is shown in security settings. You get a list of the currently installed trust agents. Right now, it's hard-coded to 1. So even if you have more, only the first one will be shown here. Maybe in the future, they will allow more. And the unlock methods that are supported by TrustLock, there is trusted device, Bluetooth, and for Bluetooth, you have to be connected to a device, of course. It has to be paired, and the interesting thing is it requires a persistent connection. So basically, if it's a smartwatch, you have to be connected to the watch, not just paired. So once the connection is broken, it locks. So the use case is watch is in your hand and phone is in your other hand, and it's unlocked. But in practice, because the range of Bluetooth is pretty big, even if you like leave your watch in the next room, sometimes it's still unlocked, so it's not very reliable. Nfc Unlock, it basically what it does, it stores the hash of the NFC ID, which is, makes sense. But for some tags, the ID is supposed to be unique. For others, it's guaranteed to be unique. But there are basically ways to clone it, so it's not exactly foolproof. Another interesting detail is that if you kind of look through the code, they mentioned something called precious, the precious tag, which is supposedly some sort of tag that supports like a interactive and more secure NFC Unlock protocol, but it hasn't been announced yet, so maybe Google will announce something around more specific, more secure NFC Unlock tag. Trusted face is simply something which was called face unlock in previous versions. You take a picture of yourself, and if you show your face, it unlocks. Another improvement compared to previous version is previously you had to like stay still for 10 seconds and don't move. Now it's continuously scanning, so even if your device is moving, it's actively searching for your face, so it's kind of easier to use, but the security level is pretty much the same. Trusted location, it's simple, uses geofencing. You set a particular location, and if you are within plus minus 100 meters of this location, the device would unlock. Here the interesting part is that it integrates with your Google account. So if you set a work or home in Google Maps, it will automatically use those locations. You can of course set a custom location and whatever. So getting more to the platform part, is full disk encryption. It was getting a lot of media attention. It's going to be enabled by default in 5.0. Is this going to be a problem for law enforcement? Why do this? Etc. etc. But on the technical side, it's basically a flag in an NFC tab. It's called force encrypt. And what it does, if force encrypt is set, then the first time you turn on the device, it automatically encrypts. For previous version, the flag is called encryptable, which is basically means that you can encrypt it, but you can also not encrypt it, left to user choice. Another improvement is that it's resumable. Before, if your, for example, device ran out of power while encrypting, it will be completely broken and you have to reset it and start again. Right now in 5.0, it remembers where it went until remembers the last block. So you can unplug and plug it again, it starts where it left off. So it's a bit more resilient. Also, it's faster. Before, it would just start from block 0 and go to the last block and encrypt everything, and it took like an hour or more. Now, if you're running XT4 or F2FS, which most modern devices are, it only encrypts the used block, so it's much faster on a new device, and it kind of makes it possible to encrypt on first boot. And like the biggest security enhancement is that it is bound to hardware. So before, you could take a device, make a copy of the encrypted partition, then put it on your computer or like a powerful server and track the encryption password or PIN offline. And because most people use the PINs like 4, maximum 6 digits, it took like minutes, literally minutes or even seconds to decrypt it. In 5.0, this cannot be done anymore because there is an additional key which is bound to the device. So if you copy it, but you don't have the actual device, you cannot decrypt it. And presumably the key is is unextractable. You cannot extract it without, even if you break the chips in parts, it's still in some secure memory. And two more usability and security features as before. Encryption required a PIN or a password. Now you can use a pattern. And you can even have an encrypted device with so-called default authentication. So when it starts, it doesn't require a password. How this looks. This is familiar. This is the same as in previous version. It asks you if you want to encrypt it. This is not really true anymore. It takes maybe not more than 10 to 15 minutes on a new device. But if the user partition is full, it can take quite a while. You have to have this option also to require PIN to start the device or not require. If you select no thanks here, the interesting thing is that it actually uses a password, but the password is always default password. It's hard-coded, which is kind of okay if you have the hardware binding, the hardware key, but if on some device that doesn't have hardware binding and the user selected no here, you can kind of crack it in a second. And of course, they allow the pattern now, which is kind of, maybe some people preferred it, but it's from a security perspective, it has less combinations than a PIN, so it's not so great. And how this is implemented under the hood in 4.4. In previous version, you have something called a crypto footer, which basically stores the keys and different metadata about encryption. It's called a footer because it's in the initial versions of the platform. It was like the last few blocks of the user data partition were dedicated to the crypto footer. On newer devices, it's on a dedicated partition, so it's not really the footer anymore. But anyway, it has different data, flags, key size. Crypto type name is basically the encryption algorithm. This is the binary master key, encrypted key. And this is a salt, and then some other data, and of some parameters if you're using script. In 5.0, there's additional data stored, encrypted up to, which is basically progress until what block you came. Then there's the hash of the first block, which is also used for resuming encryption. And the interesting things are those here, key master blob and key master blob size. This is basically the hardware bound key. And encrypted intermediate key is a sort of a hash of the key, so you can know if the password is correct or not without actually decrypting the device, which was not possible in previous versions. And how this is implemented is kind of a complicated scheme, but the important thing is this thing. This is the hardware-bound key. So you have a disk encryption key, which is generated randomly. You have a salt, also generated randomly. You put both of these to scrypt. You get a so-called intermediary key 1, which is 256 bits. It's 0 padded, so it becomes 2048, the same size as the RSA key here. So what they do then is they sign it. They sign the intermediate key with the hardware-bound key. The output is called intermediate key 2. It's again the same size, 2048 bits. And it is run through script one more time, combined with the salt, and you get something called the intermediate key 3. This is split in two parts, 128 bits for key encryption key and the same 128 for IV. They use the AES CBC mode to encrypt the key, and finally you get the encrypted disk encryption key. What it happens there is the crypto footer, the encrypted disk encryption key goes here in the master key slot. The salt also is saved, and the key master blob is also saved. So if you have those three things, you can reverse the process. And how it looks in practice, if you parse it, there's a few changes. The first is the version. Previous version it was 1.0, 1.1, and 1.2. Now it's 1.3. The key size is the same, 128. Crypto type is also the same, AES, CBC with SSV, IV, whatever, which simply means that you hash the number of the block to calculate the IV. The new part is here, Kdf Key Derivation Function. Before you had two options. Originally, PBTKF2 for Android 3.0 until 4.3, and then Scrypt in 4.4. And in 5.0 is Scrypt plus Keymaster, which is basically this. Scrypt here and here, plus the hardware key. Also, it remembers the type. So if you selected PIN, when you start the device, you will also see the number keyboard. If you selected password, you will see the alphabet keyboard, hash of the first block, etc., etc. And the Keymaster blob, this is for a Qualcomm device. For Sony or Samsung device, it probably looks different. But Keymaster blob is an encrypted RSA key, and it has a modulus public exponent IV, and this is actually the important part. The private exponent is encrypted, and the way it's encrypted is proprietary, not exactly known, but it is bound to hardware. So the encryption key is stored in the Qualcomm SoC. So if you don't have the SoC, the CPU, you cannot decrypt it. And that, of course, there's the encrypted I key, which is sort of the hash of the key. Another more obscure feature, but if you're like rooting your device and installing a super user and things like that, maybe you have had to deal with it. It was introduced in 4.4. What it is, the purpose is transparent integrity checking of block devices. So basically, it makes sure that a device is not being modified. How it works, not going to go into detail, but basically, it makes a hash of each block and then makes hashes of hashes of hashes until you get like a root hash, so so-called hash tree, and the root hash is signed. So if you can verify the root hash, you can go back the tree and verify each block. It's based on DM Verity, which was originally introduced for Chrome OS. It was then slightly modified for Android. The intended use to prevent system partition modification, which is the usual way to have a persistent rootkit is installed in the system partition and nobody even knows it's there. It's been available since 4.4, but it's not widely deployed yet. The reason for this is that OTAs is like over-the-air updates. Previously on 4.4, the way you do updates is you would patch each individual APK or jar or whatever. So if you have an OTA zip and you look inside in the the meta-in folder, there is a text file called updater script. And in 4.4, in previous version, it would look something like this. First, it will check that the APK or whatever is the one you expect. So it checks the hash. And if it's not what you're expecting, you say unexpected contents and fail. And afterwards, you basically patch it with this, like a binary diff from the previous version. And you do this for all the files. And it takes very, very long time. For 5.0, this is already used on the Nexus 9, I think. Not sure about the Nexus 6. What they do is very similar. You again check if the device you want to patch is in the state you're expecting. You check the hash. But instead of patching each individual file, it patches the whole system partition. So even if you change a single bit on the system partition, this will fail. And you get an error when you apply an OTA. So if you install super user or whatever, you will get an error. So SE Linux is been around for since 4.3 officially. What it does, it strengthens the Android sandbox, basically makes sure that application and system daemons can only access what they are allowed to access. It was available in 4.4 in enforcing mode, but only 4 domains like Vault and Zygote, and I don't remember the rest. Only 4 system daemons were in enforcing mode, and the rest were permissive, which basically means that even if there is an error, it's ignored, so you can still do bad stuff. In 5.0, it's the policy is enforcing for all domains. It's more granular, so there are a lot more rules. It's redefined, more finely tuned. And the so-called unconfined domain, which is basically a domain which is restricted but kind of can do pretty much everything. And it was used as a base policy for privileged daemons. It's now still called unconfined, but it's quite restricted. And then another change is simplified application process labeling. How this looks like in practice, if you compare the policy 4.4, there is 260 some types, and double size in 5.0, which means a more granular policy, and of course allow rules around 1,000, and here is close to 5,000. And this is the permissive domains 42, which is basically all, besides the 4 which are enforcing, and in 5.0 it's 0. So all of them are enforcing, and if you get a policy violation, you get a runtime error. Unconfined domain, it used to look like this. It doesn't really matter what this means, but if you look at the asterisk here, it basically means grant all permissions for capabilities and memory access and whatever. And in 5.0, it's more granular. The tilde here, it means negation. So you basically, you list the ones you can never have. So this asterisk has been changed to a well-defined set of things which are not permitted. So the so-called unconfined domain is really quite restricted. Application labeling is it's an interesting feature. It basically, for applications, they are all forked off of the Zygote daemon, so they have the same SE Linux context, but this doesn't really make sense. So you want to have some applications, like system applications with more permissions. So what they did for Android is introduce something called SE info, which is like basically an additional label. And the way it's used is for things signed with the platform signature, you would say the SE info to platform, and then in the policy you say SE info platform is allowed to do this and this and this. You do the same for the media, shared, and release keys, but those things were not really used. So in 5.0 is only platform, and everything else is default. There's a lot more changes. 5.0 is probably, like, security-wise, is the most, maybe the biggest security release. One thing you can come up against with developments, if you define a custom permissions, now you have to be signed with the same key to use the custom permission. So you can get some errors if you are using custom permissions across applications. Another big thing, WebView can now be updated without OTA, like via the Play Store, which is great because pretty much everything that uses ads is using WebView, and it can be a vector for infection and whatnot. Updated cryptography for HTTPS and SSL, support for forward secrecy, GSM, TLS, lots of stuff which is standard on Chrome, for example, on desktop. On the lower level, PI or PI, position independent linking is required, fortify source in Bionic, and more and more. So if you want to learn more about this stuff, which is generally boring, but if you talk about it, it means you have a breach. So nobody talks about it if everything is going all right, but if you're making the news, then you have problems. But anyway, there is feature documentation. None of this used to be documented. Now there is quite a lot of documentation. There is community stuff on the web, Android Security, G+, XDA, etc. The security vendors now secure Blue Box. They publish their research, which is usually interesting. A few books, Android Internals by Jonathan Levin, which came out like last month. It's not specifically about security, but it's very detailed. Hacker's Handbook, if you want to do, hacking and penetration testing, etc. Malware analysis, if you're interested in malware. Of course, my book is being translated in Italian, if you prefer this. Embedded Android is a bit of an older book, but also has some very nice explanation of the build system and whatnot. And that is all I have. It's only 3 minutes, so questions? Okay.
Thanks for interesting talk. And I have one question for full disk encryption, because you've mentioned that devices should provide some kind of device-specific keys to provide full disk encryption. Do you know what is for devices that were prepared for previous version of Android, like Nexus 5, which initially supported Android 4.4? And do they have this feature, or this feature is not available and they are using some kind of predefined or default device key?
It's available. If you go to security and then there is a credential storage, and if it says hardware backed, it means that it has it. It means that it's basically uses the same sort of hardware keys for disk encryption and the other stuff. So if it's hardware based, then it's most probably it's enabled. So this is for Nexus devices. Actually, like Samsung and then maybe Sony, they used to have this in previous version, but it was proprietary. So they're doing things like different way, but the same. If they all of this is trust zone based. So if the device has a trust zone support, and it's also most probably used for disk encryption as well. So
thanks.
I have a question about custom signature checking in custom permissions. Do you need to have the same signatures, or they can be different ones among two other applications, for instance?
No, the thing is, like before, you had two applications, and you find the permission in one and then use it in the other. The permission is just a string, right? So you can do anything. Like somebody can define the same permission as you, and if their application is installed before yours, it will use their permission. So this was kind of a problem, because some people were using system permissions to kind of hijack the system permissions by installing the stuff first. And right now, this check is supposed to prevent this. So if somebody installs a permission and you define the same permission, you get an error if you're not signed with the same key. So it's kind of, if it's both of them, it's your application, you have nothing to worry about. But if it's different keys, you'll get an error at the right time.
I have a quite different question. There is a lot of cool features, security features introduced in Android 5.0. Which platform do you consider more secure, Android or iOS? Do you feel that the trend that Google took with these all security enhancements is better than it's for iOS?
It's kind of a loaded question, but it really depends. iOS it has different security model. Like everything needs to be signed by Apple, and if you're not signed by Apple, it doesn't work. And they also have some, like for example, the disk encryption stuff. Apple has like a dedicated crypto processor, And on Android, this is not standard. So this dedicated crypto is better on Apple, definitely. Android certainly improving fast. Not sure which one is better at the moment, but I think they're about the same. If you're using like a latest version and you're not jailbroken or rooted, you can get the same security level. And of course, there is the walled garden model versus the free model, so it's a different thing.
I have a question about the OTA.
I can hear it, so I just, it's all right.
How many? Okay. If we disable the binary diff and we are shipping the entire blocks of memory, won't it grow to a really huge sizes, the update?
Not really, because you know the BS diff, the program they used to make those diffs is quite smart, and usually it's like, if you look at it, you have 10 files and you change the 100 bytes in all of those 10 files. It's the same. It's 100 bytes for the whole thing. So it doesn't, I mean, I don't have concrete data about it, but I think it's about the same.
And this is the very last question there, because we run out of time.
You showed us that there are some new security features, like, for example, this security enhanced Linux that right now is in enforcing mode, right? Mm-hmm. This means basically that if my application, or I have on my phone a malware, that the system will kill it, right? But as a user, if I buy a Samsung phone, mm-hmm. how can I tell that Samsung didn't switch it off? How can I be sure that all these features that you showed us that are enabled on my latest Samsung LG phone?
It's a difficult question, but you know, technically, some of this stuff, it was available in previous version, for example, in Samsung Knox and these things. So it's not exactly super new. Now it's standard, it's required by, you know, the reference implementation of Google. So specifically for AC Linux, you can download the policy, the AC policy, the thing I showed here. This thing. It's a file. It's called AC policy. You can download it. You can analyze it on your Linux machine, so you can compare it. And otherwise, you just have to go feature by feature. I mean, it's like Samsung has a different disk encryption, so it's different implementation. You have to either trust them or sign an NDA and ask them how it works.
Thank you, Nikolay. We are run out of time, so thank you very much. Many questions. If